Class, to find what we call the slant height on a three-dimensional figure like a cone or a pyramid involves use of the Pythagorean theorem. Now, which part is the slant height? It's the part that's slanting. It's this right here, as you may have guessed. Slant height is longer than what we usually just think of as the height, or perpendicular height, which is from the middle or the apex straight down at a 90-degree angle. That's going to be shorter. It's the quickest distance to the ground. Whereas the slant height's the quickest distance from the apex to a side of the base here, right? Now, if you haven't already, you maybe start to realize that if we cut this cross section, this is really an isosceles right triangle where you've got the height here. Okay, that's the height. You've got the radius of the bottom here. So that's the base or the radius of this triangle. And then what we're learning about today is the hypotenuse. That's the slant height. Okay? So we can find this if we know this and this, don't we? What's the height of this cross-section isosceles right triangle? It's 12. 12, yep. They draw it out here, so it makes me wonder, but it's the same if I went over here and went straight down. What is the base of the triangle? Not 10. 10 divided by 2, right? And finally, slant height we'll find using Pythagorean theorem, which tells us that a squared measure of b squared comes out to the measure of c squared when added. So we won't carry out the theorem here. We recognize a triple, 5, 12, 13 triangle. The slant height is 13. It's the hypotenuse of the triangle inside of the 3D figure. It's not a perpendicular height. It slants down to the side of the base. Now with a pyramid, you may be tempted to say that these are the slant heights, but in fact they are not. The slant height of a pyramid, like I was saying before, it's the shortest distance from apex to base side. So that would be actually, this is shorter from here to here, like sliding down the side. That's the slant height. And then of course we learned this is the base, and this we could say is the perpendicular height, or just height sometimes we'd say. The height of the pyramid is 20. If the base is a 30 centimeters per side square, what's the base of our cross-section triangle? It's 10. It's half of the base. And slant height, we don't know yet. So I'll just put S. Now, Pythagorean theorem would say leg plus leg is hypotenuse squared, or c squared. So 100 plus 400 is side squared. 500 is side squared. Let's see how I'm doing so far. I've gotten pretty far without looking at what the book did. This is example 2. What is the square root of, is the square root of 525? I'll just try 25 times itself. No. Might have done something wrong here. Let's problem solve. Problem solving, I realized that I used the height as my side length. When I switched to drawing this, I forgot this is 30, not 20, right? So this is not 10, half would be 15. My apologies. Sorry if that was painful for you to follow along and know that. But here you get to see me problem solve. It helps when the book does it too. I'd probably be frustrated if I found out I got this one wrong. But that's what happens. We all get things wrong. So instead of 10 squared, this is 15 squared, which is actually 225. Plus 400, that's still correct, is s squared. So this is actually 625 is s squared. And like we learned in our last lesson, to find the answer to a quadratic equation, or whatever lesson that was, it was recent, square root of 625 gives me the slant height, which comes to 25, and we're measuring in centimeters. Must not be a great pyramid of Giza by any means. Okay. Let's answer A through D, please. You got this.